Welcome back to the channel. Today we're gonna be doing the 2000 National Sprint Round problems 6 through 10. So if you guys haven't watched the first video 1 through 5, make sure to check it out. Also in the link in the description, I'll put down the questions for the test if you guys want to try it out first and then watch the video. But let's get right into the video. So the first question we're going to do today is number 6. A set of 7 integers has a median of 73, a mode of 79, and a mean of 75. What is the least possible difference between the maximum and minimum values in the set? So essentially they're asking us for the range. So we know that there should be 7 numbers. 1, 2, 3, 4, 5, 6, 7. Okay, the middle number should be 73 because it says the median is 73. And the mode is 79, and the mean is 75. So 75 times 7 is equal to 525. How do we get this? It's because we add all the numbers together, right? And then we divide by 7 is equal to 75. So the other way around, we multiply that by 7, we get 525. And now it says the mode of 79. So that means that 79 has to appear at least twice, and what should we do to make the least possible difference between the maximum and minimum values? We should make the numbers closer to each other. So 79 is already a pretty big number, and if we have a bigger number such as 80 and 81, or even like 90, then that means the first couple numbers should be a lot smaller. So if we want the range to be smaller, then we want the last number to be 79. And because it's the mode, there should be at least 2 79s there. And then pretty much now we can just plug the values in. And they have to add up to 525. So first of all, this number should be between 73 and 79, and it shouldn't be 73 because if it's 73, then that means 79 won't be the mode. So this number should be between 74 to 79. So if we try 74 first, then we get 525 minus, and then 79 times 2, 160, and divide minus 2, that's 158. Actually 158 plus 73, that's 1, and that's 3, 231, and plus another 74, we get 305, right? And then we can subtract that 305, and we get 220. So the mean of the other 3 numbers should be 220. Divide that by 3, we get that's a 7, and then 10, 73 and a third. That means that there should be some 73s in here. Well, that doesn't satisfy that the mode is 79, so can't be 74. What if it's 75? So 75, essentially we're just adding 1, so this should just be add 1, and it's 200, and it's going to be minus 306, 219. That's gonna and then if we have that, then divided by 3, we get 73. And obviously that is that also shows that these 3 numbers should be like 73, 73, 73 if we want to get it as close as together. But then that would mean that the mode isn't 75, so shouldn't be 75 either. And then we can try 76, and that's just added 2, so subtract 1 more, that should be 218. Divide by 3, that's around 72 and something, 72 and I think 2/3, right? That means there should be 2 72s, I think, and there should be some 72s and 73s, and obviously that doesn't work either. And then we can pretty much see that it doesn't work. There should be more than 2 modes, except if there's 379s. So if we have 379s, then 379s, that's 80 times 3 minus 3, 237, and then plus 73, that's 310. And then we subtract that from 525, 310, we get 215, and that's a 70, divide that by 3, right? So 71 and 2/3. So we get 71 and 2/3. Then there's no way that we're gonna get 371s in here or 372s in here, which means that the first number should be a 71. Which means that the least possible distance should be just 79 minus 71, which is 8. So in a real contest, you wouldn't need to like take that long. Maybe you would solve a little bit faster. I'm trying to explain this, so I slow it down a little bit. But during the contest, try to like go as fast as you can. Alright, so let's move on to question number 2 of today. Question 7. The third term of an arithmetic sequence is -1 and the ninth term is 20. What is the 13th term? So we know that the third term is -1 and the ninth term is 20. So what is the 13th term? So there should be, so that would be the 4th, 5th, 6th, 7th, and 8th. So in an arithmetic sequence, every time you go up a position, you add or subtract a certain number. We can see here, obviously, it's adding a number because it went from a negative to a positive. So just add a number. Let's just call it A. How many times? 1, 2, 3, 4, 5, 6, 7. I mean 6. Yeah. 1, 2, 3, 4, 5, 6. So add it 6 times. So -1 plus 6a should be 20, and then 6a should be 21, and then a should be equal to 21 over 6, which is just 7 over 2. And then we want to find the 13th term. So 10, 11, 12, 13. We add 7 and it over 2 4 times, and that cancels out to 14. So technically we're just adding 14 because we add 7 halves 4 times, which is 14, and that should just be 34. So as we can see here, the 13th term should be 34. Okay, next question. For how many integer values of x does the expression x squared plus 2x minus 19 have a negative value? Okay, so I want to know when x squared plus 2x minus 19 has a negative value. So it has to be less than 0 to be negative, right? And we can add 19 to both sides. So x squared plus 2x should be smaller than 19. Factor out the x. X times x plus 2 is smaller than 19. And then pretty much we have an equation. And then we can see what works. So first of all, let's see, like, let's start with the negatives. Which one obviously doesn't work? If it's like, let's see, if x is like -6, x is equal to -6, then -6 times -6 plus 4, so -4, that's going to be 24, which is too big. And then what about -5? So -5, it does work. -5 times, that's times -3, that's 15, that's smaller, right? And then any number in between -5 and the positive number should work. So let's see which positive number does it stop at. So we already know that 4 times 6 is 24, right? So the greatest possible x value should be 3, right? Because 3 times 3 plus 2 is 5. That's 15, right? And we already know that 4 times 6 is 24. It's too much. So it should be in the range from 15 to 3, right? How many numbers is that? So negative 5. That should be, I think, 9 terms, because there's 3 positive numbers, negative 5, so that's 5 negative terms, and of course there's a 0. So yeah, there's 9. So there's 9 integer values of x that the expression has a negative value. So our answer is 9. Okay, next problem. Let n be the number of positive integer factors of 876, 876, and let n be the number of positive integer factors of 678, 678. What is m minus n? So first of all, if we want to find the factors, we need to find the prime factorization. And first of all, what I see in both of these numbers, they all have 3 digits repeating. So 876 and then it repeats, 678 and then it repeats. So we can make it 876 times 1001, right? For both of them. And then 1001 is pretty cool number. 7, 11, and 13. That's 3 primes multiplied together. And for 876, we can prime factorize that one as well. So of course it's even, so we can get a 2 out. That's a 438. That's also even, so we get a 2 out. 219. That is not even, but the digital sum is divisible by 3, so we get a 3 out. 73, and yeah, 73 is not compatible. It's prime, so we can stop there. So the prime factorization of this number is just 2 to the second power, right, times 3 times 73, and then times 7 times 11 times 13. That's the prime factorization. About 6, 7, 8, 6, 7, 8. So using the same logic, you can get 6, 7, 8, and then 1001, which is just 7, 11, 13. 6, 7, 8 is is even, so you can get 2, 300, and 339. That's divisible by 3 because the digital sum is divisible by 3. So 113, and 113, is that prime? So I spent like a couple minutes trying to figure out if it's prime. It's not divisible by 7. It's not divisible by 11, of course. 13 either. And yeah, I don't think 113 is compatible. So 113 is prime. So prime factorization is just 2 times 3 times, composite, not compatible. Composite times 7 times 11 times 13 times 113. So that's the prime factorization of this number. And if we want to find the number of factors, then we just see the exponents and we add by 1 and then multiply together. So 2 plus 1 times 1 plus 1 times 1 plus 1. Let's see, 1, 2, 3, 4, 5. So I have to multiply that 5 times. And why do we have to add 1 every time? It's because we can have the number to the 0th power, which is just 1. So what does that mean? It means we can have a factor that doesn't include the number we have. So for example, we can have a factor that isn't even. For example, we get like 73 times 11. That doesn't have any, that's not even, so it doesn't have 2 as a factor. So yeah, so that's just 3 times 2 to the 5th power, and then this here is just 2 to the 6th power, and 2 to the 5th power is 32 times 3 is 96, and 2 to the 6th power is 64. We subtract that and we get 32. So our answer is 32 for this problem. Okay, I don't know why, but the screen became super blurry, so I refreshed it. And let's continue with our last problem today. The magic square shown is an array of the positive integers 1 through 25, such that the sum of the numbers in any row, column, or diagonal is the same. So what is the value of n in the magic square? So technically, if each row, each column, and each diagonal is the same, then each row should be a fifth of the whole sum, 1 plus 2 plus 3 plus 4 plus all the way to 25. So what is that? 1 plus 2 plus 3, 25. So we can add it up. That's 3, 6, but that's gonna take a pretty long time. And there's a small trick. So let me actually write out some more. So 23, 24, 20, I don't know where that 3 came from, and then 25. We can see 1 plus 25, that's 26. 2 plus 24, that's also 26. 3 plus 23, they all add up to 26. So we can see how many pairs there are, and then multiply by how many pairs, multiply by what the sum is. So you can see that's 1 plus 25 times 1, that's 12 pairs, right? But we have to add a 13. Why? Because 13 added no other number is equal to 26 besides itself, but we know there's only one 13 in here, so we have to add the 13 here because it doesn't have a pair. And that's just, I don't want to multiply that by 26, so I can just do this, and then that's just going to be 300 plus 13, so add it up, it's just 325. So that means we divide that by 565, which means that each row, each column, and each diagonal adds up to 65. So we see here, we're pretty fortunate, there's a lot of numbers already in here, so we can use the row or the column. So if we want to use the row, then we know that this should add up to 65. So 10 plus 12, that's 22, plus 21, that's 43, 46. So 46 plus n is equal to 65, which means n should be equal to 19. And then same for the column, let's double check. So 7 plus 13 is 20, 20 plus 25, 45, 46, same thing. We get the same equation from the column. So from both we can see that n is 19. And to just triple check, are there any 19s in here? There aren't. So we're pretty confident to say that n should be equal to 19 in here. And yeah, we're done. So make sure to stay tuned and check out the next video. It will be covering questions 11 through 15. And yeah, see you then.